Good morning, everyone. Welcome to the Best Practices and Tools for HPC NRIS Training, Episode 5. My name is Tanya Pushpadas. I'm the NRIS Training Coordinator. We have started this Best Practices session in January, and this is the 5th episode and the final in Spring Series. So today we will talk about Apptainers on HPC with use cases and examples. Before I give the dice to your instructor, Sabri, I just want to mention some logistic and some general information about us and RIS. We are a collaboration of 4 universities in Norway, University of Bergen, Oslo, Tromsø, and NTNU, together with Sigma 2, a company owns the national infrastructure in Norway. So we collaboratively operate the national infrastructure services and provided all other advanced user supported and training. This training is a part of our training and outreach program, and we are running training since a couple of years, and there will be more coming events. You could check all this in the information that you can see on the collaborative document that I shared on the Zoom chat, also that you got from email. So this is a follow-up from episode 3, where we gave an introduction to containers on clusters. And today we will talk about use cases and example. And you can have check the video recording of all these episodes in this series, which is published on YouTube channel, Andrew's YouTube channel, and all the lesson material are open and available for you for further reference. And one important information that we follow Carpentry's Code of Conduct. That means we use respective language when we share our thoughts or using this collaborative document for Q&A. As Sabri shared earlier, we use this collaborative document for asking questions and we will give answers on this collaborative document, and this will be published later. And so please avoid using any private information, sensitive information on this collaborative document, because it will be shared on live. So I would like to welcome you all, and I hope you will have a nice experience with containers today. And welcome Sabri. And Sabri, would you like to give a small intro about yourself and then start? Thank you.
Yeah, thank you, Dania, for organizing everything. Before that, so when we record, do we see the participants in our recording?
No, that is, you are not visible on the recording, but there will be an editing afterwards to make sure that we don't have any information about the participants. So it's just me and Sabri will be mostly visible.
Okay. Okay, then welcome. I work at the University of Oslo. I work, I'm in the NRIS training team as well for about now almost 10 years. These days, I'm working with this Norwegian AI cloud mostly. So these containers has become relevant in recent days, with recent developments with many different types of environments and machines and operating systems coming up. So before we start, I want you to know that if I'll be using certain documentation, tutorials which are already public on the internet, everything linked from this document. So if you get lost, you could come back to this document to find your way. So there is big link here, link to lesson material. So this is the material that I'll be following. So if you join a little later, so what I was mentioning earlier is that this document has 3 modes. One is this view mode, another one is the split mode where you could see the edits, and the third one is the edit mode. So if you click on this pencil icon, you could edit this document. So just to make sure that everybody know how to edit this, so I see already 11 people online. Please mention here whether you participated in the first part of the episode, so I could slightly modify what I'm going to talk about. Yes means O, like voting is done by placing O in front of this text, yes or no. So, okay, let's move this back. Yeah. And also, you could mention that whether if you have used GPUs, because I'll be focusing on GPUs a little later on. And also, if you had used HPC containers on HPCs, yeah, so someone else built for me. I tried it for Lumi LLMs. Okay, yeah. And also, your questions could be asked below this, and not on the Zoom chat. So this you could ask the questions here, and we will archive this as well. And later on, I have some interactive discussions. I will paste those text here as well. So our interaction primarily would take place on this document. So to get started, I will. I was here. I was using this document here, lesson material. So on the first day, we had a short introduction. What containers are, and also why we selected Apptainer. So the main reason was that we have different types of container technologies, and Apptainers fits best for the HPC setup with permissions, access, and also the possibility to transfer the pre-built containers as files instead of layers. And then we had some examples on how to use Apptainers on HPC. So by the way, the Apptainer earlier was known as Singularity. So you might see some mixing of those terms as well. Apptainer is by default available on all our systems. You don't need to load a module. And we had made this example container for you to test. And we tried it out. So the idea of kind of like a hello world, just to make sure everything is set up, was tested on the first day. For you also, I would say that maybe you could, if you have access to the terminal or VS Code or any other way to get into Saga, you could type Apptainer version, and it will print Apptainer version. So I would recommend, open a terminal or any other way you connect to Saga from or Betsy, and make sure that type this command and that it's available. So you could time to time maybe you could test certain things that I type as well. And also we emphasize the fact that not to use like random containers. There are official containers registries, and also even on those places there are trusted containers, and you have to, there are ways to sign containers as well. So you have to be cautious when you use containers as well. And then we talked about some main differences. For example, the difference between exec and run when you use containers. So the exec is used to run a very specific command using the container, and run is to run the default command. Apart from that, we talked about volume binding. Volume binding is to make sure the container can see the directories on the HPC system, or directories that are not your home directory from within the container. So the home directory, you can see it already. So here what we used was to try to access the project directory on the Intel systems. So in order to do that, we used the volume binding. For that, we have to specify dash bind and the name of the directory that you want the container to see from within, and then you could specify a location inside the container that would be mounted. For example, let's say here the directory called cluster projects NN70K Apptainer is seen as the data folder inside the container. You could also use the same name, you could mount with the same path as well. But there's this practice that you mount it with a shorter path, so you don't have to specify very long paths. And then the building container path, the lesson. Here we specified that when you build containers, your a specific location in your hard drive going to fill up in gigabytes. So it's very important that you know where it's going to happen. So there's something called the Apptainer cache that you have to set up. So you know where is it being stored, and it's easier to clear the cache later on. And then we had two programs, one bash program and one Python program that we wanted to run from within a container, or rather using a container. And then we talked about a definition file, so which is a file we create in order to construct a container. So this is a Apptainer definition file, but we used Docker container to bootstrap it. That means we use the Docker container as the basis, called the Python latest. And then okay, I'll place the so somebody asking the collaborative document link, Danya, so you could please share that. And then we copied the file called add number to a location called /opt, and then we defined the run. So if somebody trying to invoke the container, by default that program should be run using the containers environment and some help commands. And there's much more details that you might need. There are different things that you want to include in your container. So those details are available in the document as well. So there are some hidden details at some places. For example, what this means. By referring to those documents, you could get those details, because when you are actually going to build containers, you might need additional details. And the building is done on the laptop or the desktop, whichever your personal computer. Because we expect root access for this, but it's also possible to set up without root access. So the demonstration I'm going to do is going to be without root, but the expectation is that you will do it in your local computer. And the building is a specific file. But if you used Docker before, it creates layers, and it's you can't see it as specific file, so it's difficult to transfer it from one place to another. But this one, once you create it on your laptop, you could transfer it. Then we tested some jobs, how to use the containers inside the job. The main things were that so different systems might have slightly different job description, like job parameters, but the core is the same. So what we did was to have a variable that points to the container file. Otherwise, so what will happen is, if you run from the current folder, if you submit the job from the current folder, if the zip file is on the current folder, then it will pick up. But to make sure that we could move around, we can move the job file without affecting the location of the zip file. We place the zip file in one location, and we're going to specify it. And we define some variables. because this Apptainer run command could be, when you fabricate that command, it would be more readable. I guess if you followed the bash lessons closely, you talked about variables as well, how to safely refer to variables. So this command is read as, allocate some resources on one node with a very small amount of memory, and the Apptainer image is referred, and the project directory is this project directory, and the input file and the output file, and then you fabricate this Apptainer instruction. Apptainer run, bind the project directory with the same name as the project directory inside the container, and this is the location of the Apptainer file and the input, and then the outputs you have specified with variables. Yeah, so there are some downloads that you could download later on. Then I would come to today's lesson. Before I go further into the first part, I would like to mention that we have collected a lot of details here, which we will not follow like one by one. The reason is that we are trying to get all this content-related material into one place. For example, there are specific software that, how to build a container with a specific software, and then container with GPU support with OpenACC, for example. So there are specific examples. So we will talk about on the advanced section, little bit generic details. But when you actually try to do something, you might need to refer to specific software specific details as well, on how to set up parameters, for example. And then we have not repeated in the generic material to make the generic material simple, and the details in other places. And also we have external resources, the official Apptainer user guide, which has a lot of details, and also the code refinery HPC Apptainer, which is more in depth than what I'm going to talk today.
Thank you.
Do you suggest to use containers always? It depends on you. We shall discuss. Okay, so that's a good question. I mean, I am personally very pessimistic about containers. I use it when I need it. So if you can use without containers, I would recommend compiling your code using modules on the machine itself and run. So when we talk about MPI containers, you will see that the hybrid model. If the code is if the performance is very critical, by compiling it on your laptop, the compiler will not pick up HPC specific optimization options, AVX, for example. And then why not Docker on HPC? Docker requires root privilege, and you could also set it up with Docker user. So we have some details on the intro material before. And one main thing that I would like Apptainers on HPC is the ability to transfer it as a file, not as set of layers. So we don't have to upload it to Docker Hub in order to get it to the HPC system. We could create it on the laptop and then transfer it. Yeah, so all the material linked from here. So whatever I'm going to present, it's already public. All right, then I'll move on to how to. So I see since there are some questions on the Zoom chat. The Zoom chat will not be monitored by our colleagues. So you have to use the collaborative document in order to type your messages. So one reason is that Zoom chat will disappear, and like if it crashes, it will disappear as well. And we will also archive this. So please use this collaborative document. You could click on this pencil icon, the link that Dania shared, and then you could edit, include your questions here. Thank you. So we'll go to how to install Apptain on your own computer. So this one I'm going to demonstrate on a virtual machine, because if I try to make modifications to my laptop now, it might mess up things, because I have already set up it in a safe way for the tutorial. And also there might be hundreds of different flavors that you might have, different versions of operating systems, different libraries installed. So during this lesson, I don't think we can help all of you to have Docker working on your laptop or your personal laptop. But what we'll do is I'll show you on one or two systems according to the time we have, and I will point you to specific help pages and more details, and you could try it by yourself, and then you could send a support request if you want more details or if you face a specific issue. So we could help you individually. Because the specific solution that might be useful for one person might not work exactly for another person. But anyway, we'll try to install it. So this is what I mentioned, that we can't sort of cover all the flavors. But I would highly recommend that, let's say if you have an operating system and a setup and you manage to install it, please share that details with us so we can publish it on this material, on this tutorial itself with another tab. For example, now at the moment, the macOS instructions are not here. So if you know how to do it on Mac, you could share it on the shared document, so we could place it here. So these are the instructions that the bare minimal instructions that we need to install Apptainer on an Ubuntu machine. So let's follow that. So I'm just going to, okay. I'm going to go inside my container. Sorry, the virtual machine. So this you could also do it inside another container, but then it becomes a little complicated to you to see. But the best is that you would set up an environment on a virtual machine or on your laptop to build containers and then transfer to the HPC system. So I'm on a virtual machine. Then I have to add this repository. Before that, I need to do because it's Ubuntu apt update. So if it is like Red Hat, for example, you should DNF update. So as you show the first thing when I typed, it asks for the root privilege. So that's one reason that has to be somewhere you have root access. So I will become root, and then I'll do the app update. Yeah, it seems mostly up to date. And then I have to add this repository here. I'll copy paste it. It's downloading some files, and then again an app update, and then apt installed Apptainer. So you could issue a -y, so it will not ask whether you should install or not. So it will install by default. Yes. So as you see, it's getting installed, and you might see errors. There's a possibility they might get errors. So I don't recommend that you try it now, because if you're using the Zoom for the same laptop, some things might even break. So now I will ask Apptainer version. So that's how you try it. It says version not found because I typed it with wrong spelling. Then then after you install that, as a regular user, it will be available for you as well. Then a version. Then you could so not to repeat the earlier material, you could see how to use a container in this Apptainer on HPC system. We could try pooling a container and see how it works. Apptainer pool from the Docker Hub to see whether it's working. Yes, it's pulling down the container as layers. So this I use, if you see it was very fast sometimes. Sometimes it might take longer depending on whether you have done this before on the VM or the laptop, because it downloads as layers. So there's a difference between downloading and these layers. Downloading means like you take down the entire file, but the pool command work in a way that if you already have some layers on your laptop, then it uses what's there. For example, if you follow the building containers part, we use the Ubuntu base image to build our container. So if the Ubuntu base image has been used before, the layers involved in the base image would already be cached in your laptop. And then that could be used, so it will not download again. So then we have the file, container zip file, then Apptainer, let's see the default command, how it works. And then when you do that, you see that you get an error because I have not configured fully, depending on your configuration. So this error, then you could refer to the error section here. You will see that this error is related to the way it set up the user privileges. For that, you could modify this file called the central system CTL config file. That also you need to be root. What I will do is I will edit that file on a Vim editor, or you could use whatever editor you want. And then I'm going to issue this, include this restrict unprivileged user namespace instruction. So at the end, I'll include that. And then I will save and exit. To show what I edited, I'm going to use this command again to grep that what I included. So this is the instruction that would prevent this error, right? Whenever you do that, you have to reload the system files. So that's important. If you don't reload, it will not work. I use this command. It's here on the material as well. Then I will try the command again to run. Then it ran. So it detected some files and it ran without an error. So it will be some work before you set it up. You might see errors, but those errors, if you read carefully, and there are solutions already. And the way to do this is to follow the official Apptainer installation guide. So if you go to that, there are instructions to different operating systems, and if you do as they mention and then set up all the additional libraries, for example, and then set up permissions, then you would be able to get containers working on your laptop or your desktop. But it's not a direct copy paste work first time thing. So for example, this error that I showed you, that I included in the issues and possible solutions, it took some time to figure out, this is the simplest solution. There are other things you could do. So we will modify this document as it goes. Okay. So that is how I install my container on my virtual machine or a new laptop. That, if you don't have it, let's see the questions. Is in slow. Okay, so resource allocation is as the job script. We have some examples there, and you run the container as a program, as if you would run a program. Okay, so you could okay, so there are some steps given here. So the container I pulled now as an example, I build it with Docker and upload it to Docker Hub and then download it. I mean, pull it with Singularity. You need an account here to do that on Docker. So that's the part that you set up. So because I have gone through this several times on my Ubuntu setup, I know the things to do to get it set it up. So you will when you figure out how to set up on your favorite environment, I recommend that you document it so you can repeat it later on, and also include versions like the kernel and the OS with the details. Also, you could send the details to us so we could include it in a central tutorial. The second lesson that we're going to talk about is the GPU usage. So GPUs have become very relevant, especially because of machine learning and AI workloads. And also, we could ask from Ole Vidar later if he's around. So this new system coming up, Olivia, I think some of the software might be, at least in the beginning, will be available as containers. And it's important that you set up the container cache. Yes. So Ole, if you are here, do you know anything about how the Olivia software going to be? Is it going to be more containers or modules?
One thing for sure, can you hear me?
Yes.
One thing for sure is that we will see a massive use of containers because there is no way that we can update all the modules on a weekly or even daily basis. So people coming from, especially AI, they will come with containers. Of course, we'll try to have the modules and install software the old-fashioned way by configure and make install. But we know that there will be a lot of containers, so there will be full support for containers. But the details have not been worked out. So there are still some open issues, but the goal is to have full support for containers on the AI part. So you need to make the containers to run on the Grace Hopper part of the system. Of course, it's possible to run containers on the AMD part also, but then you miss the accelerators. I think that's what I know currently. So thank you.
Thank you, Olivia. So when that detail become available, we'll update with Olivia as soon as we know for certain. So for this example, so there's, I mean, I need to for the GPU example, I have created this PyTorch script. The reason that it is not just NVIDIA SMI or just to check whether the GPU is working is that seeing the GPU is not enough from the container. So you need to be able to access the CUDA libraries and actually see the device. So that's why this example. So this is a Python example here. So I don't, if you're not like a Python person, you could use if you have another program language, you could use it doesn't make a difference between what I'm going to show, but I'm going to use Python because it's easier to understand the script. So it imports PyTorch and then it's try to detect whether it can see a CUDA device, and if it can't, it falls back to CPU. So this is something you should do in the GPU when you work with GPU loads as well. And later on, when the Olivia comes up, you might have to do different setups. I don't know how the superchip works actually. So it's important to check, and there's a fallback. Because if you don't check whether the GPU is available, what would happen is you would run the code as if imagining that, expecting the GPU to be used, but it might not be used, and it might be slow, and it might just if you book a GPU and it will be wasted. And then I'm doing some matrix manipulations and printing the time here. So it's as simple as I could get for a real example. Before I do this, I have this warning here to set up the Apptainer cache. So the Apptainer cache is, if you remember, that's where the files are placed, the temporary files. So that you have to set up before you begin. Otherwise, your home directory might get filled up. Say where I made the cache. Maybe it's on the. I might have the wrong link, but I think I can find out. Build containers. Yes. So in the build containers, you will find this variable name. So for on Saga, I would recommend that you use so I'm going to Saga now. Name. I will recommend you to use this location. Cluster, work, users, your username. So this is a location that will be cleaned up time to time. But it's a safe location that will not be counted against any of your quotas, your project quotas or the home quota. But if you already have file created, if you already have a cache in your home directory, don't move it here. Just move it here, because with the privileges set up and the group ownership, even if you transfer something to this location, the quota will still be that disk usage will count the quota. So it's better to set this up upfront without doing in a default location, moving it later on. So in this location, I have created for myself maybe a Apptainer cache. Yes, I have a. Yes, I have that location. So I'm going to use that location as my Apptainer directory. So before you do anything, it's you have to set up this cache. Then I could see what I have maybe already done some things. There are 3 containers. So when I do this, some things might go faster than if you are following me, because if I had already downloaded some layers of a container that I'm going to use, it's going to be a little faster. And then I was in the GPU part. Then I'm going to have this file, the test. For that, I will maybe I go to the project directory. Projects, and then 99 the 70. And then I have a Apptainer directory here. You will also have access to this directory. Do I have any files? Let's see. What I call this file is, okay, GPU job slum. So I'm going to copy this file, maybe copy it from here. You could also type your wish. Vim to follow the material as it is, and maybe I could use the same name as this. So I called it matrix operation pi. I will increase this a little bit so you'll see that. Then I will place this here. So this is a Python program. So it uses Python and Torch. And the code is here. I'm not going to explain much about the code, but if you try to run it, I don't know what. Let's see. Just try to run it just to see the syntax errors. Okay. It didn't find PyTorch. And then what I'm going to do is, this is the Apptainer cache directory that I showed you. So I already set it up. sorry, move it. And then I'm going to pull this container from PyTorch. PyTorch with CUDA 11.8 runtime. So that, let's see here. Yes, I will pull that. So then what it'll do is it'll collect all the layers from this container from Docker Hub, and it'll create a zip file. This you could do on your laptop and transit as well, or you could do it in a login node. But I'll recommend not to do it as part of a job. So it's better that you have the file before you not do it pooling as part of a job. So then this file should be available. Docker Hub zip. So that file is there. It's about 3.1 gigabytes. And then we have a job script. I have to move it this way. Let's see whether that file is already there. If I create it, maybe not. Okay, that file is there. I can create that one. GPU test slum. So for this, I'll copy part by part just to explain a little bit. So here, the first line is the to mention that it is a bash file. So you could write job script in Python, for example. But here I'm using bash. I just include the hash tiny here because it will get copied. So here, these are instruction to slum your account. So I'm using the course account and a name for the job. I'm asking only 15 minutes. It's a very short job. Run it on single node. Later on, when we try the MPI, we'll use multiple nodes. Here, I'm asking 2 tasks, which means like you'll get 4 cores and 16 gigabytes of memory, and to use the accelerated partition. So this is where the GPUs are. So you have to mention this to get the GPUs. And then you have the GPU gress instruction, which means you can ask for 1 GPU. You can ask up to maximum of 4. So the GPU is there. And then the next part is to set the Apptainer image. So let's see whether this image is there already. I'll save this. I have to make sure the image is there, the correct path. Yes, that's the correct path. And then I will include that path here. So that is the image. And then I have this instruction. So to demonstrate this, I will do this slightly different than what this is the correct way, but I will do it in a not so correct way first, just to explain something. I will not use this env command. So this command executes this matrix.py inside the data folder. So the data folder is the current working directory of my HPC. So I'm asking the Apptainer to bind my current working directory as /data inside the Apptainer image. Then you save it. Then you can go out. I will show the file again. So this is the same file as here, except this one binding part. Maybe it will work as well depending on the system settings. Let's see. So then what I will do is I will submit this job. What was it called? Job GPU job slum. So when you submit that, you will be in a queue. Sorry. It's actually running on a node called C7-7. Let's see that node. log into that node. You don't have to do this. I'm just going to check whether it's a GPU node. NVIDIA SMI. So this is having 4 Tesla P100 cards, quite old cards, these cards. And then that node, in fact, is having GPUs. So at the end, so what I did was they submit the job, and at the end, I will see a log file. Let's see what is the last file that was created. Slum job, okay. Let's file. There are some other files here as well. So okay, so there is error here. So what it says is that there's some permission issue. Probably because of some file that I have created here. So let's check the permission of that input file. I'll take the tail of the GPU job. So let's see whether it's running still, the job. Or it has ended with an error. So when you submit an error like this, when you submit a job like this, it's very important that you go and check the error or what it is. The reason as I see it is because I have this matrix.py command here. I did not make it executable, and I didn't call it with the Python interpreter. So if I do like this, it will be Usec1 not found. If I like this, it's a permission denied. So what I'm going to do is to make this file executable and remove the older slum log files and submit it again. And see what, let's see the output. So while that it's pending, okay, while it runs, let me check the questions, if there are any questions. Okay, this when will be available? I don't know, maybe Dania knows more about this.
Yeah, that's what I typed. It will be going on pilot phase in June and expected to be in production in September after the pilot phase.
Yes. So there's the single contact point. You can, when you come here, it will be transferred to a second line for specific needs. So if your quota exceeds, you can't run containers. So there'll be so many issues if the quota is exceeded. Resolve the quota first as described here, and maybe use the work directory as I mentioned for this kind of caching. Is it always long time for? Yeah, I mean GPUs are quite long. Could be long, but if you submit a job, the way HPC work is that after submitting the job, you don't have to sit in front of the computer and wait for it. So you submit a job and come back when the results are ready. Let's see my job. It's still pending. I guess maybe many people have tried to use the GPUs. Let's see. Earlier it went well. Let's try some Unix, HPC commands to see how much of resources are free. GPU. Oh, sorry, grep. So we have 1, 2, 3, 4, 5, 6, 7, 8 nodes. Most of them are mixed, which means that there are many people who are running it. Let's see. Yeah, still pending. So until that runs, I will, the output will be available when it finishes. So what we'll do now, Dania, is that we'll have a short break, 10 minutes, and then we'll come back. And
Yes,
we'll check
Sabri, we will come back after 5 minutes after the hour. Is that a good time? Or
yeah, okay.
Yeah, please ask your question in the collaborative document we are watching in this, and I will put the break anyway. Thank
Let's have
you.
a short break and we'll come back. Yes. Okay, then shall I start?
Yes, Sabri, we are exactly on time. So are you going directly to this Slurm output, or do you want to take these last questions? I'm just trying
Yeah,
to.
I think your answer is it's very nice. That's the answer. Pooling should be on login nodes. So one reason is like internet access in compute nodes. But most important aspect is that when you reserve GPUs, as you seen now, GPUs are shortage at the moment until more GPUs come available. So you don't want to book a GPU and wait for something to download. So all your download should happen before, so your job will not wait idle while the downloading is going on. So download it on your on the login node and then submit the job.
Yeah,
And also that
another one would be like if I have this Apptainer on my Mac, I can download, means pull this on my Mac and convert to CIF and transfer that file to my Saga account. That is also a possibility, right, Sabri?
yes. So then
Um,
if you do that, then your container cache will not be filled as well. Did somebody want to mention something? Was it? Who
Yes,
that?
it was me. Just a quick discussion about this one. So I don't know how it's going to be in the future with Olivia, but when I was testing stuff, we have a different architecture on login nodes and compute node, for instance. And when I try to do something with this Apptainer thing into the compute node, I could not do it because obviously there is no internet connection. But if I do something for the installation part on the login node, the architecture is different. Then I cannot transfer it over the compute node and run things. So it was just my question of what are our plannings or what could we do if there are scenarios like this?
Yeah, so that is a very relevant question, especially for the next lesson as well for MPI optimization. So when you build containers there is something called GPU compatibility. So even if you build on the I'm now talking about the GPU the containers, not the MPI ones. You could specify to create the container in a way compatible with the GPU other than what you're building on. So that's one possibility. And the other thing is if you're compiling code that has very performance intensive, then what you could do is you could manually specify certain flags to the compiler to compile it. But all those things would not directly solve what you mentioned, whether we could compile it natively. And that native compiler, native container creation most probably would not be available because of security issues, for example. So you have to use the workarounds like specifying GPU versions other than the compilation location, and also compilation flags. And also there's that we are building up some virtual machines. So for example, the through the orchestrator, but don't try to access it now because there are limited GPUs. So using the Norwegian AI cloud, we're going to have these virtual machines which are identical to login nodes or compute nodes. So because the Olivia is not, we don't know how it's going to be set up yet. We will have architecturally similar computers as virtual machines. So that's how I'm building now. I build it in this virtual machine that identical to the login node or a compute node in that case. So you could build it in a virtual machine and transfer it to the HP system. Would that solve some of your issues?
A single more remark about this, that of course it's possible to request an interactive part of the AI nodes where you have the ARM processors and the accelerator, the CUDA installed. So you can do it manually, build your container there because everything is then the correct architecture, and then make a ZIP file, terminate the interactive job and then launch as a normal batch job. That's probably one of the simplest way that we know is working. And then we'll see what the software team can come up with of fancy stuff to help us out. Thank you.
Yeah, thank you, Sabri, for the response. And as we think, like in Olivia, I think it would be best if we create minimal containers like this that are AI specific with the minimal software that we need, so that people trying to run their AI workload can utilize those containers. So just a quick head around on that part.
Yeah, so yeah, that's a good point. That's how the Lumi setup works as well. So there'll be
Exactly. Yes.
Yeah.
Thank you.
And then so then I'll see whether my job. So it has finished, and I would like to show you something. The Slurm log that I want your attention is that it started. It's using CPU because I specifically had a test in the beginning of my script to check whether GPUs or CPUs are used. And after submitting, if you remember, I SSH to the C7-7 node and made sure there are P100 GPUs. But even though there were GPUs, it didn't use. So the metric manipulation took 16 seconds, but we booked the GPU. So in this job is an example that I booked one GPU and used it for the whole period because it was a very short period. It didn't make much of a waste, but I was not able to use the GPU. So let's submit the job again. Let's GPU example, and in this case, I'm going to include this magic instruction -nv. -nv. And then I will submit that and we'll talk about it after I submit that. So the change I did was to include this this flag. Dispatch. Okay, submit that. So that dash, we do several things. You could also do these things manually by defining it, but when you include this -nv, it makes sure the GPU access is there. Given that it's NVIDIA, but for the ROCm, there are instructions that I pasted here on the Lumi. Yeah, Lumi tutorial. It will tell you about the Lumi setup. But for this Saga, because we have NVIDIA, it will make sure that the CUDA and the CUDA compilers are at disposal for the scripts. It binds the host NVIDIA libraries. So the container can use the hardware via the operating system kernel and set some library paths. So all these things are done by using the -nv. So let's see the whether it's still waiting. Let's see. Oh, it's done. So let's see the last the Slurm log. This one. So if you see that the device using is CUDA and it took less time. I could also show the earlier one without using the -nv. So this is the one without using the -nv flag. It uses CPU and it uses 16 because it's a very simple metric manipulation with very few cells. The difference is not much. Imagine that it is some sort of like a deep learning thing. It could have run for a longer time and you would be thinking that be using a GPU. So you have to use the correct flags. And when the Olivia comes up, we'll also try to find the optimal setup for that. And maybe also, like as earlier suggested, a minimal container that would make sure that these things are used. Okay, so let's see the questions, if there are any questions. Yeah, so the way it didn't use GPU is that flag that I just mentioned, right? So then I'll move to the next one, which is the MPI setup, which is a little tricky to sort of demonstrate as well. The reason is that if you really want to compile some performance intensive code, you have to compile it on the native machine, as we have mentioned several times before. But for the demonstration, we'll try, how we can do it. And to make sure that everybody on the same page, what does MPI do? So MPI is the inter-process communication, and it allows programs to run on different machines. So basically, if you think, if you have two compute nodes, compute node A and compute node B, if you define a variable on compute node A, saying, I don't know, P equals 1, because the memory is not shared between compute node A and B, the P equal 1 is only valid inside compute node A. Compute node B, it would not make sense. But it's more complex than that. But this when the memory is not shared, you have to use some technology like this in order to make this work. And on the important thing about the containers with MPI is it uses the hybrid model, which means there's MPI libraries on the compute. We will use MPI libraries on the HPC machine, the computer that runs, and we'll make sure there's a compatible container on top of it. So you need MPI on both places for this to work. So the MPI code would run using the container, but it will also use libraries on the HPC system. There are some details here if you want to read more about this. So it uses this, it depends on the MPI flavor, it launches the MPI runner. Then we have this something called Open MPI daemon. I forgot what it stands for. Open MPI. Yeah, we'll find that out. This is a daemon that uses this needed for this process to work. And then you have the container environment, which is also using the matching versions of this MPI. So you have to be place extra attention to the fact that there is, the Slurm integration. So earlier when we run the container, we used Apptainer run something, but now we use the MPI run to run the container. So you'll see the difference in a moment. So the way the system is as if it was like a native MPI environment. So it's very important that the compatibility, we'll do a small exercise with that as well. So this compatibility finding. Yes. So for this example, I'm going to build it on using, I'm going to run this on Saga using a tool chain called FOSS 2024A. Let's see what that is first. MPI run. Okay, let's load this module load FOSS 2024A. So when you load that module, you will see there are several modules loaded. Among them is the OpenMPI 503 module. Sorry. Yeah, module. Then if you ask for the version, it will make sure that it prints the current version that is being used. So before even you start building it, you have to find the module and the MPI version that you'll be potentially be using on the machine before you build it. So that is one thing. That's one thing about hybrid model. Then I have the C program. you could the program itself is just to demonstrate the MPI the run, because it has to actually use some threads and all. So I'm not going to explain much about this code, but we can discuss it if needed. I'm going to place it in the same directory maybe. What did I call it? I called it, yeah, it's OpenMPI test. Okay, let's say. So now I have to explain something. You can't build this on Saga as a regular user. So I need to have this file on my laptop. So I'm going to transfer back to my laptop. Yes. And maybe create a directory and also a cache directory. Then I need to set up that cache I mentioned before. What did I call it? The Apptainer cache. Because even when you're building it on your laptop, it's going to take space. Okay. Now the tricky part is I'm going to build on my laptop, which has let's see what CPU it is. Sorry, it went too fast. So I have this little Indian genuine Intel CPU i7, which is like the laptop CPU, and on Saga it'll be LS CPU. Let's grab that so we'll not model name. It's Intel Xeon, and it's also like dual processors. So there are two processors on the board. So I'm going to build on an architecture which is different from the place I'm going to run. So that's one thing. And if I have MPI run here, so I have MPI version 4.1.6 on my laptop. Don't ask me why I use MPI on the laptop. So MPI you could also run on one machine on shared threads as well, apart from multiple machines. You could do that if you want. So I'm going to copy this file, which I called MPI run, was it? Yeah, MPI test. See, I'm using the same file names to reduce the amount of confusion. So I'll not use some other file name. And then I will copy that. I'm not going to explain the C code. And then if you are just compiling it, it will be something like this. Let's say with it compiles. So we don't want to build the container, and then if there's an error in the C code, then it will just waste of time. So that's why I'm trying to see whether it compiles. Yeah, so it ran on one rank, but because I didn't use the MPI run in that case. And then this is the definition file. So this definition file, we can break it down and have a look after it start compiling, because it's going to take some time to compile. So I'm going to copy this file, and it's called Saga with a specific version. So this is also important things that I'm doing. If you can see in this file, you will see. I will come back to it later. I'm building it with 503. Then I'm going to, after I issue the build command, I'll come and talk about it a little bit. So this is the definition file. and then I'll copy paste what here to build the Apptainer. Let's see how much time it will take. Okay, so while it build, I'll talk about it. So here, if you remember, I was planning to use 503. So that is why I included 503 here, because it has to be compatible with the runtime environment. So I can't, if I had built it without specifying, it might have picked up, for example, whatever I give here. And then if when you try to run it, it will create issues that will be very difficult to debug, because it's a container, and then the complications are very debug with MPI. So it's very important that you use the correct version. So let's see as an example, just to make sure that you sort of understand what I'm talking about. I'm going to paste this here as a discussion point. So this part of the file, let's see how it looks. So I have pasted this file. So if you have access to Saga, log into Saga and see what are the other FOSS modules available. Module available. FOSS. For example, let's say there's a program, MPI program that runs only with a very old version. So try to load this module, right? So 2020A. And then see what are the modifications. What are the modifications needed if using this module? If you have access, and if it's possible, just see whether, just to make sure that we understand the code, the parameters. What would you do different if you had to use the different MPI on Saga or from Betsy? See whether you can answer that. So while you answer that, let's see the building, how the building is going on. Yeah, it's building. It's going to take about 5 to maybe 5 minutes, maybe. Anyone has any input to that? So if I had to use if I had to use FOSS 2021A, what would be the first difference? Give your answers here if you know. I don't see much response.
Question there, Sabri. Yeah, okay, you already.
That's a question?
No, yeah, there is some question Ulay was answering about the MPI's things, but we could take it for the discussion.
Okay, no, we could. Is it 14 you mentioned? Oh.
13 and 14, it is, I think, following
Okay.
question.
Yeah. So I mean, Ula probably meant build it locally means build on the HP system itself. Yeah, I think it's well answered. Yes, the only way to make sure that it's, as you see, it's picking up things. When it build, it's picking up things from my laptop, because the container uses the kernel of my laptop. The kernel gives some details. When you use, for example, if you see there's the O3 used here, it might have picked up registry width of my processor, for example. So this could be overridden. If you want to override it, then you have to find the correct architecture, and then when you mention your compile options, and configurations. You could change that. But as default, it's picking up things from my laptop. Still building. But if it is very performance critical, this will not be what I'm building now would not be very optimal on the HPC system. In the level that, let's see what Ola mentioned, CS AVX 256 was AVX 512. Let's see whether they have any AVX here. But this is login node anyway, so it is AVX 512, AVX F, and so there are different versions. So in general, it's AVX 512. And then let me see my laptop, what it print up. So after the code has built, maybe you could even check what's the what it been used. So without AVX, if it doesn't mention, is it 256? If it doesn't mention version here, if it doesn't mention 512, is it 256 by default?
It depends on what compiler you're using, and most of the times it's not using 512. So I think you need to specify that you want to use the AVX2 or the AVX 512. And the AMD processors on Betsy doesn't have AVX 512, but the Olivia ones will have. And of course, if you are using some other architecture, the picture is totally different.
So in the Olivia, the ARM part of it, is ARM having some sort of a AVX kind of thing?
They are called either. Today's ARM processors we have in production in Oslo, they have the Neon, and the Neon is also available on Olivia, but they also have SVE vector instructions, and they are 128 bits, enough to accommodate for 2 double precision numbers or 1 complex double number. But there are 4 of them simultaneously, so you can run 4 of them simultaneously, each with 2 double numbers or a double complex. They have a lot of more fancy instructions. They can mask, they can do a lot of things that the Neon doesn't do. So picture is not easy. That's why we just have to rely that the compilers can do most of the work for us. And to add to that, there are a multiple of compilers available on Olivia, so who knows which one of them to use. I mean, I've done some testing and they all come out pretty well.
So is the best practice guide, is it having some instructions on compile instructions?
Yes,
Configuration.
Most of them is available it's the same as for Betsy, but I will write up a little bit more on some best practices on the processors, because we are one of the first few systems in the world with the new Turin processor. So I haven't been able to lay my hand on one of these nodes. I've been only running on the Grace Hopper nodes. But a little piece of information is that the NVIDIA software toolkit, they are different. But I need to take this phone, so yeah.
Yeah. Okay. Thank you.
Yeah, just a comment, Sabri, for if someone doesn't know the context. We are preparing, at least Ule is the main author of this best practices guide for Olivia. So that's where this compilation information and everything will be there, which will be published somewhere in September when Olivia goes production.
Yeah, thank you. Because we are like talking about these things always, we don't recognize it. Something other people might not recognize. So just to give a small context of, I don't know whether there are any deep learning people around. For example, this matrix that we multiplied, it was like 10,000 by 10,000, I think. If you think billions, and if there's a loop that has to do operations one by one, you don't want the loop to go 1 by 1 billion times. So what AVX or the registry widths would make sure that how many of those are done as chunks, whether we do it as 1000 by 1000 or 100,000 by 100,000 or whatever that number is. So those vectorization operations would greatly depend on how we compile this. So at the moment, I'm compiling it on my laptop. It'll use the process on my laptop and it'll optimize for that. So vectorization might not be optimal when I run it. So that's why the best practices guide is important, and also some basic containers that would some base container that you could build on top of it. So to answer this question, so there was this one answer that says rebuild. I will just to reiterate what I was talking. I will tell you what are the changes needed. So the first thing is that you have to module purge and use that module load was it 2021 21A and find the MPI version. This is the first thing you should do with the module. Which version you should? Oh. Module more list. It didn't load. Let's see why. Okay, I forgot the module load POS 2021. So that is how you load it. And then I'll ask the API version. It's 410 or 411. So to get the 411, let's say if you copy paste what I'm proposing here. If you copy paste this one, there are several things that will fail during the build. One is the OpenAPI version. So this URL is pointing to this file that's downloaded. So you have to change version 4 here because now it's 4.11. So version 4 and the OpenAPI version should be here. You have to change it at 4.1.1. So if you are going to use this file and adopt it, and you're going to use the different module, the 2021, you have to make sure those changes are happen. And if you copy paste this and only change 4.1.1, it will fail to download because it's version 4. So you have to little bit understand what's going on. So let's see whether the building, it's still building. While that is building, I think I had a like a earlier build version in my work folder. Let's see. So this is the one that was built. So just to show that just like black magic involved, after it finished building, I will also transfer it, but I don't want to wait for that. So I have this pre-built version. This is the same build script has been used. And then, so this is important. I'm going to use the Apptainer cache directory. Otherwise, your home directory is going to fill up with 3 containers building. You will be out of quota. So please be careful with that. And then I'm going to use this file, MPI test, MPI test dot slur. Or I'll just call it bash because it's bash. So these are the things I'm going to use. So in addition to this, I will use a reservation to start quicker, but let's see. So I have the account. This is a training account. I'm using the name Apptainer test. I'm asking 15 minutes of runtime. I'm asking to run it on 4 nodes. I see the reservation is only on 2 nodes, so I'll make it 2. and in tasks 4 tasks on distributed across 2 nodes, and total memory of 8. So if you're going to specify it in from, it will be slightly different the way you specify it. So this will work for Saga. Then I will set the let's comment this out to make it a batch Slurm instructions. Then I will make sure that I have the container. Let's see whether this container exists. 5.3. So I named it in a way that I know which module to use. ls, yeah, that exists. And also I'm going to cheat a little bit to find the allocation, the reservation. So reservation is that today for this MPI job, if you want to try it, you can, if you have applied for the course, you can run this without waiting in the queue if you use this magic here. Because I need few nodes to demonstrate this. There's a reservation setup, and thank you, Dania, for arranging that. So I'm going to use this reservation, so it will start right away. And also, it's important that load the correct modules, clear existing modules, so it doesn't interfere. Let's say if you have another version of MPI loaded alongside, we don't want that conflicting. Clear the first and explicitly load the version that your Apptainer expects. First, we went and found out the version before we even build the container, then run the container. Here, another thing is there. So MPI run, we start with the MPI run. So as earlier, we didn't start from Apptainer, we start from MPI run. So MPI run is going to start the container. And number of so for the without mentioning a like a hard number on to use how many ranks that we should use, I'm using a variable called slurm in task. So this slurm in task would be replaced with this value during runtime. Then I'll submit the job. Just have a look at the job script a little bit. And then let's see whether there's any question.
Yeah, there are questions on most of this. MBI Handule, he's answering them. I guess he is the expert there. I cannot.
Nice. Good that we are all around.
Yeah.
So the best, I mean, I would say that maybe you could experiment a little bit with this basic container and see how much the performance differs. So we have let's see the job script again. So I have this basic. Okay, I forgot the shebang here. Okay, the bash and the basic job parameters, Apptainer location, and I'm starting with MPI run here. So let's back that and see whether submission requested reservation is invalid. Okay, let's see. CPU, okay. Because at the end, if you see, I have a typo. I have a G at the end, so that's why I didn't pick it up. Now it's running. Let's see the job. Because I use this cheat code, no waiting, and it is running on 2 nodes on rack 1, C1, on 26 and 27. Let's see how that ends up. It finished. Let's see the result. Yes. So it picked up 4 ranks. That means the MPI setup worked. At least there was no library conflicts, or there was no seg fault, or something like that. So it actually picked up the MPI and it worked. And if you see, there are 4 tasks were used, only 90% of the CPU used, because the load is very minimal. And you could try with different flags. For example, when I compile it, it's still compiling. Instead of picking it up, asking the compiler to automatically pick up the optimizations, you could specify AVX512 and see whether this makes a difference with performance. Yes, so that's the details that we are going to talk today. We're going to discuss more on questions and things. What we have provided in this tutorial is very basic but real payloads for GPUs and MPI. And we will, if you have any Fortran code that we could use to measure AVX performance, for example, you could share it with us, and we could make kind of a benchmarking setup here as well, whether it makes a difference if you use different ways of compiling than automatically picking up your laptop setup. Yes, can I run MPI jobs with SRAM? Yes, both should work. Earlier, we had this predicament of using Intel MPI, for example. But Ulla, do we have Intel tool chains around, or it's gone?
Intel compiler is one of the best, so that will also find its way over to the AMD partition on Olivia. It's a bit unofficial because Cray is not too happy with it, and of course it's an Intel compiler using the AMD processor, so you need to take care so you actually can utilize all the goodies with the AMD processors. So that needs some special treatment.
And also this SRAM, yes, when you call SRAM, it'll use some of the parameters, but the recommendation is to explicitly use MPI run inside a job script. So when you do S batch, it will run using Slurm. How do you manage MPI job dependencies and coordination when running large-scale containerized application across multiple nodes in cluster? So if I take the last pass, multiple nodes, the MPI libraries would take care of it. So it doesn't matter whether you recruit 2 nodes or 1,000 nodes if you use the proper programming techniques. And it's better to maybe plot your performance and see there might be some optimal number of nodes that you could ask. Because this MPI you need, there's some time for provisioning as well. So just increasing the nodes without any benchmarking might not increase the performance. So you have to find the optimal point for that. Large scale means if you could mention whether it's large data or large number of iterations, we could talk a little bit about it. So when you build containers, normally we try to avoid including the data inside the container, but instead have it on the cluster of parallel file system and bind it inside the container so the container would see it. Yeah, so the performance questions. Yeah, so I think that's all we're going to mention. Anything else, Ulla, that you want to mention here?
I'm a bit concerned about SRAM in MPI runs inside the container. That should be okay. But is SRAM available inside the container by default?
No. SRAM is not available inside the container. I didn't include that.
Yeah.
And also, Ullavidar, like we talk about PMI and PMIX, for example. So there are so many things that like not fully detailed in this. So this is the basic example. So you don't need srun inside the container, because the way we invoke the container is not using the container to run MPI run, but instead of MPI run to invoke the container. So in the example, what we use is the system MPI run, the HPC systems MPI run, to invoke the container as if it was MPI program. So the other way around would be that we have the Apptainer calling a program, and it will use something inside that. So that's why this hybrid is the most, I mean, at least by the HPC expert, they recommend hybrid to use build a container, select MPI version, open MPI version that you want to use, and then build the container accordingly and use a hybrid run model.
So I'm normally saying that I met some resistance, but not that much. That a container is just a fancy executable, and you see from your take on this here is that the MPI run launched a very special executable called Apptainer. And the Apptainer has a lot of goodies inside it. But from the system point of view, it's just a fancy executable called Apptainer.
Yeah.
Which is making it a bit easier to understand.
Yeah, thank you for that description.
Sabri, can you share the collaborative document? I just want to mention that we are collecting feedbacks. So at the end of the document, you can write something you like today and something you want us to improve next time when we run similar courses. So please use this collaborative document to give us feedback. It's very important, and we really like to have your feedbacks. Is there anything specifically you want to discuss further, Sabri? We have still 8 minutes to wrap it up. You are muted.
So I'm not going to mention anything new for now, but if there's any specific question, we could answer. And I could also like to point out, for example, there's more things. For example, if you want a big DFT, is Espen around?
Yes, I can see him as a participant.
Yeah, so he might know some big chemistry, quantum chemistry stuff, for example, that might need special attention. And also the code refinery material that has more descriptive. There's a lot of description here. If you want to find out what a layer is, and the MPI, more details about how MPI works, and more descriptive details about provisioning the MPI, the launcher, and then how the queue manager kind of run this, as Ullavidar said, this special executable, and all the layers and other stuff involved. Understanding this might be especially useful when you want to debug when something goes wrong. And then we used OpenMPI, so you can also use the MPI CH version of it. So if you do that, you have to build the container accordingly. So this has a lot of details about how it works, and it also gives you some optimization options on different computers, Saga, some instructions here, how to build optimized containers, and also Lumi. We have a definition file for Lumi. You can use it as a basis for building Lumi containers. This is the Alto, the Finnish computer. So here it would be nice to have a more specific details. Apart from that, any last words, Espen, you want to mention, or Dania, before we wrap it up?
I don't have much, but just a kind reminder to give feedback. And you will get a summary email from me when this recording is published and the collaborative document is archived and published. So I thank you so much, Sabri, for taking this effort to write this tutorial as well as delivering 2 sessions based on containers. And Ule, your presence was invaluable with the MBI questions. Otherwise, I had to ping you if you were not here. So thank you so much for your help during this session. And thank you all for your attendance. And I hope you had something to take away home and use containers in the future. Just a kind reminder that you can always ask us help by sending an email to support@tenris.no. Our support staff will be happy to help you. And with Olivia coming, you can expect more training on this, on different topics on scientific computing and how to run your programs on the new system. Yes, thank you so much and have a great after lunchtime. I guess it's almost lunchtime. Everyone is hungry, and thank you.
See you around. Bye-bye. Thank you, Dania, for organizing all these things. And also, thank you, Gula, for helping us with this MPI stuff. Thank you. Bye-bye.
Bye.